To continue the explanation of the steps of genetic algorithm, we can see here after we initialize the population with the random solutions and we calculate the fitness functions and the ratio. And for the selection, we can use the roulette here after calculating the ratios in the previous slide. So we can see here these solutions have the high opportunity to be selected, which with high values. So how to select? Like I will generate a random number between real number between 0 to 100. That number, if the generated number it is below 16.5, so the solution number x1 will be selected to be improved. If the solution or the random generated between 16.5 to 36.7, so x2 will be selected. If the number generated between 36.7 to 43.1, so x3 will be selected. If the generated number is between 75.2 to 100, so x6 will be selected, and so on. So for example, here, if the random generated, random to be selected, random number 1, to try to improve these solutions. So which solution to be, let's say, if let me remove this one, I suggest like 16, so x1 will be generated. But here it will show that like I try to follow the sequence. No, I want to generate another number. Let's say the number that generated randomly from the equation in the code, so generate a random number between 0 to 100. Maybe that number is 60.5. Okay, 60.5. So you go to the roulette, 60.5, in which area it is between 49.5 and 75. So here this one is x5. So x5 will be selected. So x5, now I want to generate the new x5. New x5. What is new x5 here? Later, I'll try to do what we'll have for this new x5. So this x5, that parameter will be selected to be improved. Now I'm in step 6. Create a pair of springs. Create a pair of springs chromosome by applying genetic operator crossover and mutation. So here I will create two pair of chromosomes. So here, based on crossover or mutation will generate only one. So here you generate based on the crossover, maybe you can generate two new solutions. But if we follow the steps here, I want only to improve solution number 5. So solution number 5, now I will do crossover. So let's based on the probability. So I will have the probability crossover is 0.7 based on how we initialize in the early of the step number 1. So I will have also another random number to be used here to make a decision whether to do crossover or mutation. So let's say if I want to do crossover, a random number for crossover. For crossover, I will generate a random number between 0 to 1. So it's a real number generated. If the random real number generated for crossover is 0.37. So in the code, I listed that points if the generated RC or random crossover less than 0.7, then do crossover. So here, so I will do crossover. Okay. So to do crossover, so then do crossover for x5. So, and then I have to select which pair that need to be do crossover with the x5. Here you can use some techniques, as I said. They can select the best, or maybe also you call the roulette to select the second number to be crossover with this x5, or you can pick up randomly. So let's say I will pick up, do crossover for x5 with x, let's say x2, with x2. So here I just pick any chromosome by x2. So x5, what are the values for x5? x5 have 0, 1, 1, 1. This is x5, and x2 is 0, 1, 0, 0. Okay, so I will have these two here chromosomes, and then I will do, let's say, 1 point crossover. 1 point crossover. So 1 point, maybe I select, if I select, let's say, this part to do 1 point crossover. So the new solutions here, the new solutions will have a 0. So these values here will be replaced by these values, 0, 1, 0, 1, and then that will be 0, 1, 1, 0. Okay, so here this one will be x. So here will be x, new x5, so here let's say I will just only reduce this one, new x5, and this one new x2. Okay, so I will have, based on this crossover, I will generate, sorry, okay, so I will have a new x5 and new x2. Okay, so I did crossover. Maybe I don't do mutation here, I just do crossover for this, and then I have a new 2 pair, or because here I just want to do for x5, so I have this one solution for x5. If I want to ignore x2, I can ignore it. Some could, you can, let's say you add the both to the population size, but here I want to improve, so x. So here I will have a new x5 equal new x5 equal 0, 1, 0, 1. Okay, so then I will have this one new x5, which is 0, 1, 0, 1. So let's say I will move now to step number